Hi everybody, this is Steve, Steve Rowe, otherwise known as Libra Steve. This video is to just share with you what I've been learning about using Raku and Jupyter. Jupyter coming from the Python world, and we'll see it in a minute, but it's a great interactive tool for literate programming. And in particular, I wanted to show you today using Jupyter with the module I wrote called Physics-Measure. Right, so you can see I've got the GitHub page on the screen here, and there's a GitHub repo called raku-Physics-Measure, which is the main code. This one is called raku-Physics-Measure-Jupyter, and I've just broken this out so it makes it really clear and easy what you need to do to get the combination of Raku and Physics-Measure and Jupyter running. And you'll notice there's a Docker file in here, which is already using a Docker image I create automatically. This is Python Jupyter kernel already made, and then on here I'm installing math polygons and physics measure, physics constant, physics navigation, which you'll see in action in a minute. And then going back to the README, that gives us pretty simple instructions on how to get this all up and running. So let's give that a try. So the idea of this talk is to just go through the steps I would normally go through to get this up and running. So I use a tool called CLI AWS EC2 Simple, which has a little command line. So I can basically look at my Amazon Web Services EC2 instances with a Raku command from my command line. And you'll see I'm already running one. I'm running several here, but there's already running one called RPMJK. I'll actually create a new one. I'll show you in a second. I'll just get this started. So I'm going no setup for this and then launch. So that's going to create a new Amazon instance. Just while that's happening, I'll show you what's behind the scenes in the config. So vi.roars config. Can't remember that. It'll come to me in a minute anyway. Probably easier than just to show you the RAW's command options. So if you just do it without a command, it will show you the options as with any Raku script, unless you is doing no setup. There's basically a YAML in the config. The key thing here is I've discovered with lots of trial and error that Jupyter needs a certain level of EC2 instance. A T3 small is kind of the smallest one that runs it without crashing the Raku kernel. So I think the Raku kernel is quite computationally heavy. Anyway, you can see here I've created a new instance of an Amazon EC2 machine. I'm just going to pick up, so I know it's running now, and this is what the connect command does, is gives me a little connect string I can use to connect directly to the server, so you can see it here. Cool. So I've got the server running, and if I just pick up the IP address as well while we're doing that. So now what I want to do is on the server is run this command here per the instructions. It's Ubuntu, standard Ubuntu needs a sudo. So it's going to load and run that. Cool, I'll let that go on in the background now. So here's one I did earlier. So this is me logged into a Jupyter notebook. You'll have, you'll see a bunch of files. That's basically the root directory here. This script puts everything in work EG for now. And here's an area I've been working, which is rect maths. Okay, so let's show you that in action. So as you probably know, Jupyter, you can restart a kernel. You see it's the Raku kernel here on the top right. So I'm going to restart that kernel. This is on a different machine that's already running. And then I've got 2 or 3 cells in here. So I just click the top cell and start to step down and run these. So you can see it's got, it's using libraries and so on. It's putting out results pretty interactively. Raku can be quite slow sometimes. So I'm very pleased that this scale of machines that does the job. Right, and just, you can obviously read this, later on, but basically I've taken a very simple polygon module that I started with that has a notion of an SVG drawing, and then this first section mixes in physics measure, so it has basically child classes that specialize with an extra scale factor, and that scale factor is a unit. And you can see here that's units of m for meters. Okay, fair enough. Then you would so the only difference now when I'm using and consuming that new class is I've got to remember to put the m in front of everything, because that's how I defined it. But then I can use, instead of just using real numbers, literals, I can use this Libra and then quote marks 30 meters, 20 meters, 100 feet, and so on. So what the Libra does is it's the physics measure kind of literal helper that then gives you space to put in a string with a number, and within that string you start with a number, some digits, and you finish with some letters, and the grammar will split those up and read it, so it can happily know if you've got things like feet and meters going on, and automatically do the conversions. And then you can change stuff around, so that might be 100. What else can we use? 1,000 inches. Let's see what that does. Just change that and rerun the cell. So it's told you there's a different size, and look, 1,000 inches is a heck of a lot more than a few feet. So my square is very big now. So yeah, so it's just showing something fun, really, as that's going on. Anyway, there'll be lots more stuff on Jupyter, as I share with you the information. But I want to show you how interactive that can be if you can set it up like I just showed you. So here it is. We've now downloaded that image, and I have to, looking at my instructions, go in there and run this command. I'm afraid right now it only runs as root and so on. And then what I need to remember is when it does that, it's creating me a secret, so I can copy that. Now I want to go 18.170.31.169. Just got the IP address, and this is on port 8888. That gets me into the running server, and I can log in. And you can see that's the clone that we've been using already up and running for you. That will shut down automatically. Okay, be careful because this class of EC2 is chargeable with Amazon, so make sure you terminate it. You can do that here by going, RAWs EC2 terminate, or if you have a console, you just look at that. Okay, and obviously the IP address. So the other thing to mention before I terminate it is, because we came in an interactive mode to start things up, if I go Control P, Control Q, then that detaches me from that Docker process to do, but still leaves it running. So that means that when Amazon cuts off my terminal SSH connection, it doesn't bring down the server, and it will run on then. So that way you can share a Jupyter Raku server with your colleagues. And then finally, I'll just terminate the whole thing, stop spending money. Appreciate your interest in this stuff. Please do just PM me on Discord, or otherwise email me at librasteve@furnival.net, and look forward to hearing any feedback you might have.